Namaste, हमेशा खुश रहो बिटिया. I am JVN Dr.Anamika Ahirwar, Associate Professor in the Department of Science and Technology at Jayoti Vidyapeeth Women's University, Jaipur. Today I am going to take the lecture on the topic sagas. Uh, you see here in this diagram, there's a start transaction and there's two commits. Okay, and there's the partition of the commits. Okay, and here you see the rollback. Rollback, as I told you, that revert back the process. If there is some type of error, means there is here our process is blocked, or you can say aborted, so it will back to the previous one. Okay, so the problem is here. If I see the problem of here, then it will abort if, and see the process here. Okay, so here rollback and abort are doing their work. If this is aborted, then here this starts from there. So this split a long T sagas, okay, into arbitrary many shorter sub T1 to T2. A commit commit of a sub T makes the changes visible to the rest of the world. Means an abort roll back the sub T's, they then recover with help of compensating CTs. Okay, commit transactions. Okay, if TK fails, that means the transactions are this is executed. Okay, so the transactions will be rolled back to a chosen commit. So this saga support long running transactions activities, but sagas are not suitable for compensating and compensating an unpredictable, that is, you can say, dynamic T activities. This is the case where the user is controlling the T, means in terms of interactive mode. Okay, so these two extensions of chain transactions concept are: the first is the, in this saga, defines a chain of transactions as a unit of control. This unit of control is called as the saga, and it uses the compensation idea from multi-level transactions to make the entire chain atomic. And the next is the back the back chain of compensating transactions are as the established as the original chain proceed in a forward direction. The next is the compensating transactions can also be transactions effect should be saga abort even when another unrelated transactions have already executed. So here there is a condition of abort. Okay, so this saga relax the restrictions that the subtractions of the saga executed. Ninth is the additional concurrency that can be gained that and typed by the specific concurrency control. So the next is, you can say, sagas are an alternative mini batches. Okay, mini batches I discussed about the previous videos, so just go through it. Then this is a graphical representation of sagas. You see here A is trigger to this A. Okay, so this and this B is here the deactive, and if this A is trigger to B, okay, so that means this as a whole B in this there this B triggers to A triggers to B. Now again here the pointer comes to the C, and this C triggers to B, because we have only limited nodes. So it is a very good step taken by the university. Now here you see cooperative transactions, means in this they are talking about the corporates. In this, in business transactions are going on, if because we have data, so you need to require this. For this, the a solution from design space is that our design team designers open look at each other's incomplete, or you can say inconsistent results to guide their own work. So there are some examples like computer aided design, case applications. Okay, so a software concept can be cooperative, and transactions allow transactions to view each other's partial results under the clean performance. Now here you see that this is a bad, you can say, if in this check individual model, means this is a model and x, and the x is what go to this domain, and for this go to the domain this for xyz, suppose any resources, it is for back to x. Now come to the checks in check out. What is that? There are one possible schema to support cooperative work. Okay, so um, users watching the corporate checkout for alert for checkout objects from the digital DB into a private workplace. The next is the private workshop. Users operate on the object outside the DB concurrency control. Next, in private workspace, users operate on the object outside the DBR. DBR, which this will ensure normal concurrency control. The entire collection of operations in the private workplace should be workplace appear through a special. So for if we are talking about the work, so when work is finished, the objects are checked in to the global database, which occurs enforce normal concurrency control. The entire collection of operations in the private workplace appear in a single transaction. Now another is the check in and check out solutions can improve control and improve. So you can say the entire collection operations private workplace appear in a single transactions. The check in and check pop organization checkout operations are normal, that means short to affection against the global, that is DB. So the next is the The check-in, check-out of schema supports flexible concurrency control while not requiring changes to the DB concurrency control. But it delegates which must be responsible for university. So the check sequences, or, or you can say might. In this, the check-in, check-out schema supports flexible concurrency control while not regarding changes to the DB concurrency control, but displays uh, recovery context, it but it's like control by requiring the changes from the DB concurrency control, but delegates which must be the responsibility of this month and concurrency control of others. So this is the saga, okay, and this is not in your syllabus actually. Here we are talking about not talking about the xenophoenix in systems because this is not in your syllabus, but in brief I'll let you tell you something about this. This is basically developed by Talina Research and Development and Dr. Ole Jagren and Finson. They are based on the two ideas basically. First is the non-acid but acid. Okay, so relaxing the rules of the conflict serializability and modified nested transactions model in the subsections. And this is the website you can go through this snomic system. Sorry. Now come to the nested conflict serializability. Sorry. Conflict serializability, that is CCSR. Okay. For this classical conflict serializability, there are basically two operations are conflicting and if at least one of them is a right operation. The next is the conditional conflict serializability. Applications can use reads write with quality parameters. So what are these parameters? If I'm talking about that, let A and B, there are two sets of quality parameter. These are the parameter values. So WA and RB denotes write and read operations. So these write and read will conflict with each other unless A is a subset of B. So the example is a set of available parameter value is good, medium or bad, and the W that means write and read words conflict. The application programmers to needs to basically understand the semantics of the parameter value. The transaction manager does not. Now the next is the formalism. Means this is the only change in the definition of conflict. Means the generalized serializability theorem is that a transaction history is CCSR if and only if its conditional conflict graph is acyclic. Okay, what I am saying is the graph should be acyclic. Now this CCSR can be enrolled by 2 PL. whereas if CCSR can be enforced by 2PL, and this transaction stores that are requires strict on strict etc. Motorola module CCSR can be defined. How means that there is a formal foundation for non-compensating based recovery. Example of this are the CCRR also offers automatic recovery. In this, no compensation transactions are necessary. Now come to the NCSR, means nested conflict serializability. In this, the right sphere of the control, that is WSOC, can be seen at a single user database. Okay, so for this, the idea replaced by a single user WSOS who which models and this is the idea is replace single with the multi-user. Okay, so the other users can then execute transactions within this dynamically created DBSOC on behalf of the transactions that created it, and this can be extended to arbitrary number of levels nested databases. Okay, so if we enforce conflict serializability uh, as the correctness criterion at all levels, nested conflict serializability. So this should be like should be checked in all levels, and this NCSR generalized CSR by along the sequence of operations within WSOC to be serializable rather than serial, thus applying CSR recursively. So you can say this idea allows arbitrary complex patterns of collaborative involving two or more users, right? So the next is the OOMG transactions IOO object. This I will discuss in the next video.